That's all coming up, but right now let's talk about Java. This year's annual Java One conference is taking place at Moscone Center in San Francisco. It's kind of the annual get-together for all the Java programmers and device developers and stuff. And companies like Oracle and Nokia are there. Even NASA is there. The National Aeronautics and Space Administration uses NASA. And to show us what they're doing right now, two of NASA's senior software engineers from the Goddard Space Flight Center in Maryland, Troy Ames and Jeremy Jones. Welcome to the Screensavers. Great to have you guys. Your background, Java programming or C or C++? What is, Jeremy?
All of the above, really.
All of the above? Did you find it hard to move from C to Java? It seems pretty similar, yeah?
It's pretty natural, yeah.
Yeah. Now, Java is like C++, an object-oriented language. I think kind of a nicer, cleaner interface from my point of view.
Yeah.
Do you like it better?
Oh, absolutely.
Yeah.
We haven't really done much in anything else since.
Really?
Yeah.
Almost all your development now is in Java?
In our group, yeah, not all of NASA.
And why is that?
Well, there aren't really any disadvantages to it anymore unless you're doing something really special like maybe hardware device drivers or something. But
well, Troy's doing something that I would have said if you'd asked me, if somebody had come to me and said, I want a specification for this, I would have never said Java. We'll take a look at it in a second. It's surprising what he's able to do with Java. Let's take a look at what you've been doing, Jeremy.
Sure. Well, this is a tool that we wrote for astronomers to use to create their observations on a telescope like the Hubble Space Telescope.
So an astronomer has some time. He's been assigned some time on Hubble, which is very, very valuable. He wants to plan what he's going to do with that time. He uses this software to do that?
Yeah, basically, it's a collection of tools that they would use to create their observations. And what you're seeing right now, for example, is an image of the sky. And these squares are an image of the footprint of what the instrument would see if it was projected onto the sky.
So he's going to try to create some coordinates for the telescope to search, basically.
Right.
Now, would you do this in the past? Have they done this by hand? How would they do it?
Yeah, well, you know, in the past they would they would edit text files and things, and actually for things like what I'm doing here, positioning the apertures, if you will, on the sky, they would even do things like cut out little pieces of paper and then put them on a desk and actually orient them together. And
No
things
kidding,
like that.
really?
So it was all by hand.
So they must love this.
Yeah, they do, actually.
Now, what does Java help you when you're doing this? Why is Java a good choice?
Well, for the cross-platform nature is one of the
runs
main
on
reasons.
anything.
Yeah, astronomers use lots of different kinds. They use Solaris and Windows NT and Linux and stuff. So that was a main reason. Also, we're doing a lot of graphical stuff and visualizations and things like that, and Java's really good for that. The Java 2D and the Swing and all that makes that sort of thing really easy.
Swing is the user interface libraries that give you native user interfaces across all platforms, and this looks like a real Windows application. You don't give up any of that that elegance.
Yeah.
And you find that Java is pretty quick to develop in for you?
Oh yeah, and the productivity is a lot better than with like C++.
Yeah, great turnaround times. All right, hey, that's a neat application. I can see why an astronomer would just look at this. What is that?
We're using Java 3D here to do what we call a 3D surface plot of an area of the image. So you can see.
Look how fast that is.
What we're doing is we're graphing the intensity of the pixels on the image, which is important for determining, you know, when one object on the sky is a little less bright than the other, and things like that.
Wow, really cool. Thank you, Jeremy. Let me come over here and look at what Troy's up to. You're doing data acquisition, is that right, Troy?
Right. This is the instrument control, remote control project, and what we're actually doing is controlling instruments. NASA has a wide variety of instruments and a wide variety of environments. So what we actually do is describe the instrument and the environment using XML, and then we read that description in, and this software actually configures itself based on the description of the instrument.
That's really cool, because you can use an instrument that wasn't invented when this software was written, and it can automatically announce itself to the software.
And actually, in this case, we are just connecting up to a simulator that's simulating an instrument. And
so the above is the noisy data, and then below the cleaned up data that we're getting from the instrument.
You can actually plug in algorithms and chain them together to get the processing you want.
That's really incredible.
And this shows a simple example of doing that, removing the noise
now,
from the data.
When we started, I said, this is an application, if you had said, I want to do real-time data acquisition, I would have never spec'd Java for that. I mean, that's something you do almost in assembly language because you want the performance, right? Java's fast enough to keep up with that?
Yes, well, we found it, in many cases it is. In this case, the instrument is writing data, we're using Java native interface, and the instrument is writing data about 15 megabytes per second.
Wow.
And we're getting that into the Java environment and processing it.
That's really remarkable. I mean, it shows you how far Java has come. You could probably write, if you could do 15 megabytes a second of data, you could probably write video games in Java pretty happily. So it looks like NASA's going to keep using Java. Is that right, guys? You feel like it's a good platform for you? That's great. Neat stuff. I really thank you for coming in and showing us a little bit of what Java can do. It's made me rethink what Java's capable of, I have to say. It's pretty cool. And I appreciate you coming in and giving us a peek a little bit at Java technology in astronomy. If you want to see more about Troy Ames and Jeremy Jones' work, of course, you could go to the NASA Flight Center or the Goddard, or you go to thescreensavers.com. Another great place. Thank you, guys. Appreciate you coming by. Pat, what you got now?